So hi everyone, in this video we're going to be going over the transformation of trigonometric functions and exactly how you'd go about doing that. So in the last video we looked at the core trig functions such as sine, cosine, and tangent, but in this one we're going to look at what happens when they're moved around a little bit. So as you can see on the right side of this board, I've written the general form, so it looks like it's a sine b times x minus c plus d. I've just put sine in there even though you could put cos or tan. Just going to explain it using sine for now. And on the left side, I've got graph paper up with 45-degree intervals put there just because it's the easiest thing to do. So I'm going to start off by explaining the general form. So let's start off with A. So A, B, C, and D are all constants. So depending on what they are, the function will be different. So A is the amplitude. So what the amplitude means is the height on either side of the principal axis. So we've got some things to clarify here. So first of all, what is the principal axis? So the principal axis is basically like the foundation of the function. So in this case, sine starts at 0 and ends at 0 in terms of like the y coordinate. So that means the principal axis would be this line over here, which is y is equal to 0, because the graph revolves around that area. So I'm just going to draw an ordinary sine curve here. Actually, I think it might have been helpful if I had drawn this earlier, but it's okay, I'll draw it now. So that's a general sine curve. So the principal axis is this line over here. And the amplitude is actually this distance up here between the two. It's like the peaks. So this over here is 1 and here is 1. It's length 1 because 0 to 1 is 1. So what this means is the amplitude is 1 because on either side of the principal axis, the maximum height is 1 of the function. So what we could do is if we made the amplitude 2, then this function, the new function, would go up here instead. But it would still have the same 0 since you're only changing the amplitude. So it looks something like that. It would look like a more stretched out version. And if it was 0.5, it would go down lower, but still have the same zeros as well. So that's the amplitude. Let me erase that. So next what we have is, let me go. So next I'm going to go to this side over here. This is known as the vertical shift. So as you can see, it's not directly attached to the function, it's just like an addition. So what this means is that the vertical shift will cause the entire function as it is to move up or down. So for example, if the vertical shift is 1, instead of starting at 0.0 here, it will start at 0.1. And the maximum at 90 degrees would not be at 1, but it would be at 2. And then the 180 degrees will be at 1, 270 will be at 0 instead of negative 1 because you're moving everything up by 1 if the value of d is 1. Let me just draw that again. So very rough sketch, but that's approximately what sine x plus 1 would look like. So it's just a vertical shift in either direction. So if the d value is negative, the function moves down. If the d value is positive, it moves up by whatever value d is. So let's write that down. Shifts by d units up or down. So vertically. So now let's go on to explain the more complicated ones, such as b. So I'm going to draw a line down here. So b refers to the period. And I touched on this a bit in the last video, but it was a bit confusing the way I did it. So essentially, the period is the number of complete cycles of the graph within a specific time frame. So in this case, we know that the normal sine function has a period of 360 degrees, since that's how long one full cycle of the function takes place. But if the period became 2, for example, that means that 2 full cycles would take place in that same 360-degree period. So basically just dictates how many of the cycles take place in that 360-degree time frame for sine and cosine, because tangent is obviously 180 degrees instead. So what that means is that it's like sort of serves as like a horizontal compression of some sort. You can also deduce, let me just change the color. So you can also deduce that the number of degrees required for one cycle is 360 over b. So what that means is that if b is 2, then the period for the new function would be 180 degrees, in that one full cycle will take place in 180 degrees. So let's just see how that might look. So if the period is, if the value of b is 2, then that means that the function will take place twice within this 360-degree frame, and therefore once within the 180-degree frame. So instead of 90 being a maximum, it will be a 0. 45 will be a maximum. 135 will be a minimum, and then 180 will be as it is. Just repeat that with the other part. So 225 would be a maximum. 270 would be a 0. 315 would be a minimum, and 360 would be obviously 0. So if we connect the dots, that would look something like this. And yes, I know art is not my best subject in this case. So as you can see, it's much more visibly compressed than the original function, which is a bit longer. That's because more cycles are taking place in a smaller time frame, of course. So that's what the b value represents. And that leaves us with one last thing, the value of c. So I'm going to drag this out here. Unfortunately, I didn't leave myself enough space, but that's okay. So the value of c in this case refers to the horizontal shift. So it's basically representative of the same thing as d, except in this case, it shifts it horizontally. So shifts by c units horizontally. So it just shifts the entire function to the left or right. So one common thing to keep in mind with this is that if c is a negative value, then that actually means that the function goes towards the right and not the left. If c is a positive value, it goes to the left. I know that's not intuitive, considering that on a number line the positive is to the right instead of the left, but it's also worth pointing out that the negative sign exists. So if there's a negative value of c, it should move to the right because the two negatives cancel out to make a positive, and vice versa. So that's just something to keep note of. So for example, if c is 360 degrees, the function would still remain the same because you're just moving it 360 degrees to the left. But then again, this function only requires 360 degrees to do a full turn. But let's say you're moving it by 90 degrees. So I'll just keep this color. So 90 degrees means that all the values will move. If c was 90 degrees, then the function would move to the right. No, it would move to the left, sorry, because obviously see, I got a bit confused there, but like, as I said, it's not intuitive. So if it's 90 degrees, then it moves to the left. So what that means is this 180-degree value will move to 90 instead. Then the maximum at 90 will move to the 0 point. Then 270 will move to 180. So the value of 270 is -1. So now 180 will have the new -1. And then 360 will become 270. And then so on. So it would look something like this. And as you can see, this looks like it's a cosine curve. So what we can also deduce is that sine of x minus 90 degrees is the same as the cosine function, if you might notice that. So that's just an example of how you would use c to move the function around. Just before I wrap up the video, I would also like to mention that you should use your calculator. They can actually make it really easy to do these problems. So, for example, if they give you a function just hit the table button, as I talked about this in the last video. Hit the table function, insert the function, type it in, and then make it so it steps every 45 degrees, since that's a good interval to have. And then what you want to do is you want to plot all the points that are generated, because they give you the x and y coordinates, and then connect them using the general shape you know. And that's actually a really good way of doing these kind of problems. It kind of allows you to check if you're right, and if you have absolutely no idea, it's like an option that you can use. And it just saves you the trouble of having to visualize it, because it can become quite challenging. Just to ensure that we have practice though, in the next video we'll go over some of the kinds of questions you might be asked around this, and practice transforming these functions with more than just one transformation. And we'll also do a video soon about radians and what exactly they are, how to use them, etc. So just like a guide to radians. Thanks so much for watching the video, and see you in the next one.